Facilitator is online now. All
Okay.
right, good evening, ladies and gentlemen. If you are just joining us, wherever you are joining us all over the world, you're welcome to Transformation 2060, a program designed for all science educators in Ogun State. Of course, Ogun State is known as the education capitals of the Federal Republic of Nigeria. And we were doing this just for all of us to know that the bedrock of all sciences, which we call mathematics, it is high time we look for a designated place for this particular subject in our school to serve as a lab in all our school. And tonight we have one of our erudite scholar who will be, going on with us on what we call curating mathematics content to mitigate distraction and entertainment bias in students. So this developing, engaging, and focused educational material is for mathematics clinic, and of course, and I've said mathematics clinic. So I hand you over to Dr. Lukacs tonight. Over to you, Doctor.
Okay, yeah, thank you very much, Dr. Adewale Kayode. And first of all, I would like to wish you a safe trip to Abuja. And I appreciate you for inviting me for the yet another, interactive program. So, Dr. Kayode, you've been doing well when it comes to, organizing a kind of educational program, so aiming at transforming education, in particular the STEM, so which of course includes mathematics. So this is not the first time we will be collaborating on such, and I must say that when it comes to you know working with people or collaborating with people, associating myself with like minds. So I have to say that you are one of them, and thank you very much again for inviting me. So again, my name is Gafari Lukumon, as he has rightly introduced. So I'm an educator, researcher, and I'm the founder of Math with Lukgaf. So, and a platform, an online platform, so where I demystify mathematics in our mother tongue Yoruba language. So I'm passionate about demystifying mathematics using culture, context, and creativity. And as Dr. Kayode introduced, so my background blends rigorous mathematics, so real world application and creative teaching. So, and as you are going to be seeing in my talk, so my initiative, Maths with Lukgaf, is a community-based and online initiative that brings mathematics closer to everyday life. So, because I focus on relatable, local, and humorous examples, especially from Yoruba language, culture, and context. So, and I've created this group. It's available across social media, on WhatsApp, on Facebook, and classrooms. So, reaching both rural and urban, learners. So, I'm confident and happy to say that, so far I've created more than 500 examples shared in short lessons and videos. And some of these lessons are available on radio stations and libraries. So under the theme Transformation 2060, so which is about one clinic per school, the STEM resource hubs for independent learning mathematics. So I'll be discussing, how to develop an engaging and focused educational materials for mathematics clinics. So you will agree with me that as a mathematician, we are all a doctor. And if a student is suffering from mathematics illness, we should be able to diagnose and admit such students to our clinics. So with the aim of getting rid of that illness and sickness. And I'm going to showcase how I've turned Maths with Lukgaf to a clinic. So whereby students who are suffering from mathematics phobia and mathematics sickness, so we are I've been able to treat them. So with that, so because of the time, this will be the outline of my talk. So in the first part of my talk, I'm going to discuss about who I am. Of course, I've actually summarized that. So in the first part of the lesson. So and what about my mathematics clinic, which I've done. So then I'm going to post a question on whether we actually need a mathematics clinic. I hope you are following. And then I'm going to give you, a practical, relatable examples that connect and stick from my clinic. So that connect to students, so that if you are planning to create your clinic, our target now is to have a clinic per school. So it means if you are planning to, have your own clinic in your school, so probably you can use some of this insight from my initiative, from my own clinic, from my own mathematics clinic. So in order to create yours, so it doesn't matter to use the same example as mine. It doesn't matter you use the same context as mine, but of course you can use practical, relatable examples that connect or that is relevant to your immediate environment. So for example, now you can see that Dr. Kayode Adewale teaches mathematics in Ijebu. So he call it U0. So if you're also from Ijebu or you are from Egba, you can also use a relatable examples so that are applicable to where you are coming from. I hope you understand that now. So that's what I'm going to do in the second part of the lessons. So I'm going to give you a practical example of what I've been able to do so far and how I've been able to achieve that. So likewise, I'm going to share testimonies from some of these practical examples. Like I've mentioned, so there are practical examples that I have used. So, and those examples connect and stick to students. So they are beneficial to them. So then I'm going to show you some of these testimonies. And if time permits us, I'm going to present some of the study on the impact of AI power tools. So that wherever you are planning to, create on your own mathematics clinic in your school, so then you should be able to harness some of the wisdom of AI. So in order to make your classes engaging. So in fact, there are some of these publications so we've published, and some of them under review, that shows that students learn better when the content is presented using an A power tool. So then I'm going to conclude the lesson. If we have question and answer, as you can see, I don't need to stress myself on this. So as I mentioned the other time, I'm Dr. Gafari Lukumon, and I'm an educator, researcher, and the founder of Mathematics with Lukgaf. I'm passionate about teaching people what I know. So, and I demystify mathematics in Yoruba, so using culture, cultural context and creativity. And my background blends rigorous mathematics, real world application, and creative teaching. And about the initiative, which is my clinic, is a community-based and online interactive that brings mathematics closer to everyday life. So let me now pose you a question. Okay, now, before then, this is my clinic. As you can see, this is a screenshot from my YouTube channel. So currently I have roughly, 550 videos. And these videos, are those, that concepts that treated student illness across levels. Like I've said, it's a mathematics clinic, and as a mathematician, you're supposed to be a doctor, such a way that when you diagnose a problem in students, then you should be able to, apply, any relevant medicine in mathematics that you think is going to help the student. So far, my video spans across levels, from high school up to undergraduate. So not only mathematics, but statistics. How do I create this clinic? So how, I use this, what I call a relatable example to teach my students. So which I want you to take insights from to create your mathematics clinic as well. As you can see, hard programming, partial fraction solves, UTME series, explanation of, engineering mathematics in Yoruba and so on. But let me pose you a question. Do you think we really need a mathematics clinic? Do you think we really need a mathematics clinic? Unfortunately, I might not be able to see, people answering, but you can be sending your comments on YouTube as well. So I will tell you that we definitely need a mathematics clinic. Anytime I'm presenting, like this, I'm giving a presentation such as this. I used to use a screenshot of this guy, and you can see this guy. He's solving a mathematics question, or supposedly solving a mathematics question, and he was sweating heavily. And if you check the second picture, in the right hand side of my screen, you will see that the other guy is also suffering from mathematics phobia. You understand now? Then it means an illness was diagnosed on those two students. You understand now? So then it is very important for us to diagnose or to find a cure to cure this kind of disease. So you agree with me that when you take 10 students and you are trying to take a survey of, out of all the 10 students, how many of those students prefer or likes mathematics? So you will agree with me that it will be hard for you to see one out of the 10 students who will say confidently that, oh, I'm passionate about mathematics, I like the concept. It will be very hard to see, that. But you won't, waste your time. It will be very easy, to find 9 out of the 10 students who are going to tell you categorically that, oh, they hate this subject. Oh, mathematics is very difficult. I hope you understand now. So how do we now make this mathematics? How do we make it easier for students? How do we solve, some of this phobia in students? How are we going to get rid of all these illness they have? So in order for them to get rid of the illness. So I hope you are following me. If you have a question, you can just place it on the chat box. Then I'm going to reply that. Okay, now how do I build my clinic? I mentioned that in my clinic I try to use a kind of relatable examples, so whereby students can actually follow the lessons. And for them, if they are able to follow the lessons, then their illness, that is their phobia for this concept, so will be cured. So then, if time permits us, I'm going to share like 5 or 6 of them before I actually show you some of the insights from our research on AI power tools. I hope we are following. So the first example I'm going to give, like I've mentioned the other time, anytime I'm teaching my students any concept, I try to look for a kind of relatable examples, so that can enable them to understand the concept. You understand now? So probably an example that is suitable to their immediate environment, or probably if there is any trendy slang, I try to use this. So one of them is the word Ganusi. I think, I'm sorry to say this because I know my audience are, mainly people, teachers from Ogun State. And I think this event actually happened in Ogun State as well. So whereby the popular, Fuji musician, King Waswahinde Masha. So when he was, doing burial ceremony for his mom, and he was asking, I don't want to quote him verbatim, but he was telling someone who was asking him, oh, Alaji, how do you think the funeral ceremony is going to go? Then was saying, ilé bàbá mi wà ní Fápọ̀tẹ̀, so àwọn àfà wọn lọ síbẹ̀, ọ̀dọ̀ kìíní kan náà. So that is the scholars, so the clerics, so they didn't go to his father's house in Fidipote, but they all come to his house. Ganusi. You understand now? This slang has been trending since then. So the word Ganusi. So then when I saw this slang, or I watched the video, I tried to, blend it with my mathematics context. And so far, what I use it for was, teaching differentiation and integration. You understand now? And I used to I told my student then, okay, now today let us Ganusi differentiation and integration. A student, even if a student ate mathematics before, hearing the word Ganusi, which is also a trendy slang, in our community, they will be more, aroused to learn the mathematics concept. And I say that, I use it to teach the linearity property. And when we say linearity property in algebra, we have the factor addition and scalar multiplication. For example, when you have two factors u and phi, for example, and you have a scalar k. So when you have your f of u plus v, it's the same thing as f of u plus f of v. That is factor addition. In essence, it means you are going to operate the function onto each of the factors. So that's why we have f of u plus f of v. That's factor addition. So likewise, we have scalar multiplication. Scalar multiplication is, when we have a scalar is like a number, a constant, as you can see there. So, when you have f of ku, for example, where k is a constant, the same thing as kf of u. That is scalar multiplication. So when, an operator satisfies these two properties, we say such operator satisfies linearity property. And one of such operator is differential operator. And invite integral operator also satisfy linearity property. That's what you are seeing on the screen now. For example, when I have my f of s, which is a function, so which gives k, is equal to k g of x plus v h of s, and you are asked to differentiate such function. It means you can use derivative to Ganusi, each of the term. We have two terms here. kg of x and vh of x. When you have your differentiation, it means you can use derivative to Ganusi each of them. Then we are going to have kg prime of s. We know g prime of s is derivative plus vh prime of s. Can you see that now? When students recall, Ganusi, okay, it means if I have two functions, or two variables, or more than two functions, and I want to differentiate them, I can use derivative to Ganusi each of them. I hope you understand now. So that's one of them. Another thing, example I want to give, which I think is related, I'm very sorry for using such example, because the second example is about a TAPist who has just died, Baba Charles Agbako. I think he was also a native of Ogun State before his demise. And one day I was teaching differentiation again, and I came across our exponential function e raised power x. And e raised power x is stubborn. No matter the number of times you differentiate this particular function, it will keep giving you the function again. When I have y is equal to e raised power s, we know the derivative of e raised power is also e raised power s. And since derivative is a function, when you have a function and you differentiate it, you are going to have a function back. It means since what you differentiated is a function and it gives you a function back, it means you can still differentiate it. That's why we have a higher order derivative. I hope you understand now. So for example, you have f prime of s, which is first order. We have f prime prime of s, second order. F prime 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 of s, fourth order. In fact, you have f hundredth of x, which means when you differentiate a function 100 times. But what is strange about this particular function e raised power s is that no matter the number of times you differentiate it, no matter the number of times you use derivative to Danaya, I'm sorry, I hope you understand the meaning. So when you use derivative to Danaya, and so it will keep giving you the same e raised power s. That's why I call it an Agbako function. And when they say someone is Agbako, you know what that means? It means the person is very stubborn. You understand now? So the person is what do we call it? A rebel. So likewise in the mathematics world, we can link in e raised by s to an Agbako function, because no matter the number of times you differentiate this particular function, is going to remain the same. And you can see now, I'm very happy to show you that despite using this example, I can see, AI that is Gemini. So, if you just type an Agbako function now, it is recognized on Gemini that in the context of the Facebook post, which was referring to my post I made, so it means it refers to a mathematical function, e raised by s. So this function name Agbako, because it remains unchanged, regardless of how many times it is differentiated, because the derivative of e raised by s is also e raised by s. If you tell your student, okay, an Agbako function, even the person is suffering from mathematics phobia, the moment you say, oh, Agbako, oh, say Papa Agbako. So, you are going to create a kind of, arousal on the part of the student, and, is going to, follow the topic. And next time he or she comes across e raised by s in the exam, e raised by s, it's an Agbako function. It will remain just like that. What I'm trying to say in essence is that if you are planning to build your mathematics clinic, which of course, Dr. Kayode and most of us are, we enjoy you to do, try and be using, a kind of a relatable example that is very close to your students, so that they can record the subject, so that you can, easily take care of what they are suffering from. So another example I'm going to give you, which is about one of the exam I've used, is known as Ajawure. You'll be surprised that, okay, now what is the meaning of this Ajawure? What I mean by Ajawure is that, I was teaching, when we say the combination of dog and goat, we know goat is Iwure and dog is Aja. Ajawure is the combination of these two animals. I hope you understand now. We know that when I have 3 dogs inside the room and I have 4, goats inside the same room, and they ask you to go to that room and count the total number of, animals there, will you say, oh, I can see 7 Ajawure? You won't say 7 Ajawure. You can either say, okay, now I saw 7 dogs and 3 goats. I hope you understand now. When you say Ajawure, I was using this kind of, a comical example when I was teaching, a student the concept of complex number. We know, a complex number, when we are, although this is not relevant to secondary school, but, anytime I'm teaching, my students, so the number system, after I've explained the real numbers to them, they've actually seen real number as the highest system of number in mathematics. But I used to tell them that, okay, no. So apart from a real number, we still have complex numbers. So which combines, the combination of real numbers and imaginary number. We know where the imaginary number comes from. So before, we know that, when we take square root of a particular number, so it's going to give you, an answer, so which actually, translates to the number you are going to multiply by itself, and 2 times to give you the number inside the radical. Square root of 4 is 2. Why? Because 2 times 2 is going to give you 4. In fact, we can say it is also minus 2, because minus 2 times minus 2 is going to give me 4 as well. I hope you understand that. But mathematicians are working one day, and they came across, a square root of negative number. And we know that when we have something inside the radical, which is square root of a number, we know square root of a number is a number you are going to multiply by itself twice to give you the number inside the radical. And mathematicians are now working, they came across -1 inside the radical. What is the square root of -1? What am I going to multiply by itself twice to give you -1? People might be thinking 1, is it? No, because 1 times 1 will not give me -1. People might be saying, oh, -1? No, you are wrong, because -1 times -1 will give you 1, not -1. That such number, don't say it doesn't exist. Just say we don't know it. Because if I ask you now, where does the atmosphere ends? Or when this world is going to come to an end? Don't say, no, this world is not going to come to an end. No, you don't know. You understand now? And in mathematics, even if you don't know a concept in mathematics, you just say you don't know it. I hope you understand. And don't say it doesn't, the cosansa for no. So that's why mathematics, a mathematician symbolizes square root of -1 as I. I hope you understand now. And I is also the same thing as square root of -1, of course. So when you square the both sides, you can see that I square is equal to -1. So that's the imaginary number. But this is not where I'm going. So where I'm trying to go is, when you are now adding complex numbers together, so you add the real part with the real part, the imaginary part with the imaginary part. Look at the first example in the right-hand side of my screen. We have 6 plus 4i plus 12 minus 2i. So those numbers with I are called the imaginary part of that complex number. 6 plus 4i is a complex number. I hope you understand now. But from that 6 plus 4i, 6 is the imaginary part of that number. I hope you understand now. So, and 4i is the imaginary part. So it means if you want to add these two complex numbers together, then I explain to my student that, okay, now don't say Ajawure, because some students might say, okay, now 6 plus 4i, 10i. I now told them that don't say 10i, because when you have, a dog and a goat inside the same room, you won't say they are Ajawure, or are we going to say Ajawure? That is not correct. So it means you are going to count dog with dog and goat with goat. I hope you understand now. So it means when you want to do something of this, when you are adding, complex numbers together, so the students will know that, okay, now since we can't have Ajawure, we can only have Aja and dog separately. So then the students will understand that, so if I also want to add complex number together, I'm going to add real part with real part, imaginary part with imaginary part. I hope you understand that. That's why from there we have 6 plus 12 is equal to 18. Then the imaginary part, which is 4i minus 2i, so it's going to give you 2i. I hope we are following. So that's one of the example. It means, so whenever you are planning to create your own mathematics clinic, which of course you agree with me now that it is very important you create one, so try and take into account, relatable examples. So when you are trying to teach your concept. Okay, now let us go to another example which have been used in my clinic, and that example is Emilokan. I think maybe I will agree partially with Dr. Kayode now that probably Ogun State is the hub of education in Nigeria, because you can see now that the first example I used on Ganusi, the second example on Agbako function, and this example now of Emilokan actually happened in Ogun State as well. During the electioneering period in Nigeria, the current President Bola Ahmed Tinubu, went to Ogun State, and I thought, prior to the primary election of APC, and things was very high. People don't know who is going to emerge as the APC flag bearer. And the president, you will have watched that video as well, was that I was the one who put this current, the former president there, Muhammadu Buhari, that Muhammadu Buhari came to my house then on Sunkulori television. Mo á pé kó mo Sunkulori television ẹnu ojú ẹnu. Torí pé ó ṣèké ní olùlẹ̀, ó ṣèkejì olùlẹ̀, ó ṣẹlẹ̀kẹta olùlẹ̀, wọ́n á sunkún káàkiri lórí television. So I hope you understand the scenario. Okay, now Emilokan. We know how that came. Then I tried to use that trending slang Emilokan then, so to teach, the concept of calculus as well. We know that in calculus, you have different kind of approach. So you can use to differentiate a function based on, how the function comes. So for example, when you have your function in terms of polynomial, you can use your linearity property and, differentiate each of these functions. But you can also have your function in forms of product. When you have product of two functions, then you are going to use what we call product rule. We have quotient rule. So you are going to use quotient rule when you have your function in form of fraction. I hope you understand now. So likewise, we have a chain rule, so which is used for what? A composite function. You know where I use this, a local slang was this. Then when I started teaching, what do we call it? Composite function. Then I explained to my students that, okay, now, whenever you see a function first, check if that function is in form of fraction. When the function is in form of fraction, you can apply your quotient rule directly. When the function is not in form of fraction, and you can separate two or more functions separately. For example, when I have e raised power x sine x, you know, e raised power x is a function on its own, sine x is also a function on its own. In this case, we are going to use product rule. I hope you understand that. But when you have e raised power 5s, you can't use product rule. That's why when you are going to use quotient rule. Then I mentioned to my student that, okay, now when you apply your product rule, TOC yani pe olo product rule, olule, olo chain rule, olo quotient rule, olule, olo linearity property, olule, chain rule, ó ní ẹgbẹ́ kíní ìwá èmi ló kàn. You know, a student suffering from mathematics phobia, hearing this, that, oh, èmi ló kàn, you know, they will, be very happy, and they will be, highly motivated to, follow the concept next time. I hope you understand now. So, in essence, when you are trying to create your own mathematics clinic, which of course we also, advise and encourage you to do, then try and okay, I can see people saying the network is not bad. I don't know if it's actually from my side. Is it from my side or from yours? Can you hear me, by the way? Please, you can reply on the YouTube. Okay, thank you very much. Hey, somebody say the network is okay. Yeah, let us go ahead. I hope you can see now. I think I agree partially with Dr. Kayode that Ogun State might be the hub of education. You can see my examples. All those examples I'm using actually came from Ogun State as well. Okay, now to proceed. One of the examples I use in my clinic, so you might be, I'm just taking, a calculus, because you can see all these concepts, the e raised power x, the calculus itself, so the Agbako functions, the Emilokan, they are all centered on the same topics. I have for some of these examples for each of the topics I'm teaching. I have for set, for simultaneous equation. I'm going to show you some for the simultaneous equation. One of such example is taking phone as a function. Anytime I want to introduce differentiation and integration to my student, I will just tell them, okay, now the phone you are using to watch this video, or the laptop you are using to watch me, please smash it on the ground. If you can do that, the student may say, oh, I see this Dr. Lukgaf, so why will I smash it on the floor? It's not possible. I hope you understand now. Then I'm now going to follow it. I try to pose the question to them. Then they will be waiting for what I'm going to say next. Then I'll now say, okay, now what you've done is what? You have differentiated. Then I just link in their phone and laptop to what? To a function waiting to be differentiated. And as soon as they smash their phone on the ground, what they've done is differentiation. And maybe now you smash your phone on the ground. Maybe you want to follow my instruction. Oh, okay, my instructor, asked me to smash my phone on the ground. Please don't do that though, because probably I don't know if you are using an iPhone. So maybe if you now smash your iPhone on the ground, I can't give you my own tenor survey. I'm using so I hope you understand now. So when you smash the phone on the ground, what you've done is differentiate. You've differentiated, and the process of repairing the phone back. Say, we cry, oh, look, I will collect my phone back, oh, I will collect my laptop back, oh. The process of repairing the phone back to, what you have originally is called integration. And that's why I have an adage I used to say at this junction that, okay, now if you don't know how to integrate, don't differentiate. Do you know the meaning now? Who can tell us the meaning? If you know how to integrate, don't differentiate. That is, if you don't know how to repair, don't destroy. I hope you understand now. So in your own clinic, you should find something, people can actually joke with to understand the concept. I hope you understand now. So because differentiation is the reverse process of integration. And that's why when you integrate, we used to add the constant of integration to it. I hope you understand that, because the constant of integration, Yoruba will say, Ojo apo le shekini o, Ojo apo le jojo ara. And your phone now, if you place it down, so even if they repair it, it won't look as like what you had originally. I hope you understand that. That's why when we have a follow come screen. So when the follow come screen is destroyed, there is no way you can't have it. What you have originally again. I hope you understand that. So that's one of the example I gave. So in essence, I'm also encouraging you that anytime you want to, have your own clinic, so make sure that those clinics, are equipped. So with a medicine, with some medicines, and that medicine should be, using an example, a relatable examples. So within your vicinity, because of the time, let me give you one more example, and I think that will be the sixth one. Anytime I want to teach elimination method, when you are solving simultaneous equation, you tell your student that we have 3 methods of solving, simultaneous equation. So we have elimination method, so we have substitution method, and we have the graphical method. And I noticed that anytime I'm explaining, the elimination method to my students, they find it difficult. You understand now? So so I also observe that some teachers also complicate it for them. Anytime I want to teach them, what I'm going to do is that I will ask them that, okay, now you first of all decide on which of the variable you want to eliminate. Okay, now when you have your system in form of x and y, decide which element you want to, which variable you want to eliminate. I hope you understand now. Okay, let's say you agree that you want to eliminate x, then I will now follow it that, okay, now before you can eliminate x, you have to ensure that the coefficients, of x in all this system of equations are equal. Maybe, for example, when I have 2 systems of linear equations, so I have equation 1 and equation 2, and if I want to eliminate, x, before I find the value of y, then I must ensure that the coefficient of x in the 2 of the equations are equal. How do you make it equal? Then I used to use an example of rice and beans. I will not tell my students, okay, now suppose you have rice and your friend has beans. You know what we want to achieve is to have a kind of equations, the 2 equations where they have of course 2 distinct coefficients in the 2 equation before. We want to ensure that the 2 equations are now having the same coefficient in terms of x. Then I'll now ask them, okay, now suppose you have rice and I have beans, and both of us want to eat rice and beans. What are we going to do? Students will tell you, uncle, rice there for me now. Can you there for me? That's okay now. If you want to ensure that the coefficient of the 2 system of linear equation are equal, just give your friend rice, and give your friend rice, and your friend give you beans. Then both of you are going to eat rice and beans. What I'm trying to say in essence is that if you look at this kind of example now, so we have method of elimination. We have 3x plus 2y is equal to 7, 5x minus 3y is equal to 37. Assuming we are interested in what? In eliminating the value of in eliminating the variable x. You know what you are going to do in elimination method is to eliminate a variable to find the value of the other variable. You understand that if you eliminate x, you find y. As soon as you find the value of y, you can find x again. Then I will now ask them, okay, now eliminate x. And don't forget what I told them. Before you eliminate x, you must ensure that what? The coefficients of x in both equations are equal. It means in equation 1, x is having 3 as its coefficient. In equation 2, it is having 5 as its coefficient. I want to ensure that the coefficient of S is equal in the two equations. What you can do is to just linking it to this rice and beans, give equation 1 rice and give equation 2 beans. In essence, multiply 5 by equation 1 and multiply 3 by equation 2. You know, if we do that, we are going to have 15 as the coefficient of the two equations. I hope you understand now. You know, if you can use this kind of example whenever your students, you know, are trying to solve simultaneous equation and they want to employ elimination method, you know, their mind will come to, oh yeah, let me just give this guy rice and he give me beans. That is that. And because of the time, let me just, stop for the use of this example. So these are some of these testimonies I've gathered. So which is telling you that if you follow this approach in designing your own mathematics clinic, people are going to like it. For example, for this Agbako function I use, you can see, you know, I got roughly 80 likes then, and you know, many people are sharing it, and people will say, oh, so funny. Even those who hate mathematics, and somebody mentioned, oh, Agbako function ni Alare yen. You understand that you can also confirm E raised by S to be an Agbako function because of the comical way I introduced it. And you know, one of my Oga mentioned, oh, keep up the good work. And you know, this Oga told me the day we met that, okay, Gafari, although I'm not a mathematician and I don't understand, E raised by S, but I conceive from your explanation that E raised by S is indeed an Agbako. Because you know, no matter the number of times it was differentiated, it remains as E raised by S as well. You can see a lot of people cheering me and, you know, giving kundus. You understand now? You can see that I didn't prepare that on the slide. I want to tell you that I've also used kundus, as one of the examples to explain concept to my students. You understand now? You know, there was a training video 2 weeks ago that, okay, now, before I came to Abuja, I used to, see your work. Kundusi. So I also use that kundus to teach a concept. So in essence, when you want to create your own mathematics clinic, use a relatable example. That's what I'm trying to say. So because of the time, let me now move to the second part of the lessons. Apart from using a relatable examples, I want to encourage us to, harness the wisdom of the AI, the artificial intelligence in teaching your students. You agree with me that AI has come to stay, whether we like it or not. So AI will remain with us. And you know, people, are of two types when it comes to using AI in teaching or even in research. You will hear some people saying, oh, don't use AI. Why we use AI? You are training people to be, to be lazy. I recall a scenario when I was in a school before, and you know, they they banned the use of calculator. Well, although of course it is good, but I think when I see mathematics, as a way of understanding the underlying principle guiding it, getting, to know about the subject or the content from scratch. You understand now? If you know the content, you know, I've been to some of the countries whereby when they are doing the examination, they are still going to give them formula sheet. And you know, if you have been marking Cambridge examination or you have been teaching a student from UK or the United States, you will agree with me that, you know, for each of the examination, they are going to give them, a formula sheet. The reason for giving them is that they don't want them to cram anything. What they want them to do is to just apply what they've known. And that's why, you know, if you are following us on Adle Ishiro, you know, I used to tell the participant that all these questions I'm going to give you, you might not need to, use your pen. You know, it's what I call residual knowledge. The question that is going to test your what? Your residual knowledge. Okay, now, so these studies on AI power tools, so I'm one of those who say, okay, now we should be using AI, but we have to be careful to it. But I've run some studies, myself and some of my colleagues, on the impact of these AI power tools in the teaching of mathematics. And one of them is, harnessing AI power tools in problem solving. And we use an experimental approach. So whereby we randomly assign students into two groups. And one of the students, we gave them questions. We call it an open test examination, open book test. We told one of the groups that they should use, a ChatGPT, which is an AI powered tools, large language model, LLM. And we asked the second group of students to use their textbook or the handout. So they are free to use any book material, but they should not use their phone or they should not use ChatGPT. That is RCT. And in science, when we call something hierarchy of evidence. What I mean by hierarchy of evidence is that when you are interested in finding an evidence, or maybe when you are looking for causality, and causality, what cause what, and you want to you are looking for an evidence in science, they arrange evidence in hierarchy, in chronological order. And the least place, or this place where you can get knowledge from is from the expert opinion. An expert can be biased. The reason for this is that an expert can be biased. Okay, now if they ask you now, or they ask me, I'm from Oyo State. If they ask me, okay, now where do you think is the of education in Nigeria? Because I'm from Oyo State, I will tell you it is from Oyo State. You understand now? I might be biased in my response. I hope you understand now. So that's why the weakest evidence is the evidence that comes from the expert, or that comes from someone. Somebody can just say, oh, don't drink cold water. You understand now? Yeah, because the person might not substantiate the claim with probably an empirical finding, or the claim might not be backed up with any empirical findings. So the next in that order is from case study. Because of the time, so we also have RCT, randomized controlled trial. That is the gold standard. So whereby you can, you place people at random, and you test for the causality. Before you can use randomized controlled trial, you must be testing for the causality, and you must be, manipulating variables. I hope you understand. Now you can see that what we are manipulating in this case is what? Those who use AI in solving the problem. And the second categories are those who actually use the traditional approach, so which is the use of textbook. I hope you understand now. Then after that, we measure the speed as well as the accuracy. So the speed, after which all the students, submitted their work, and we measured the accuracy as well. So the question we gave them was on sum to infinity, and we designed a rubric which is just for 3 points and 1 mark for writing the formula for the sum to infinity. The second point goes a correct step. So then the last one is for the correct answer. So then we just calculated this to to get the accuracy score. And then at the end of the day, so this is what we had. We find out that those who use AI, that is ChatGPT, are more accurate than their counterparts who use the traditional open book approach. So, but we couldn't find a significant difference for the speed. I hope you understand. And this might be because of the fact that when we pre-registered the study, so it was revealed that we are going to need 240 subjects, but we actually got 93. So it means when we have a larger sample, it means we might be able to detect the speed effect as well. But what I want you to take into account here is that you should also incorporate AI as one of your medicine in the mathematics clinic you are going to incorporate, because you can see the effect of accuracy here. So that is when you give your students, or when you allow them to use AI, so when they are trying to teach, so when you give them question, it means it's going to assist them with their accuracy. So okay, now another one is the use of Kahoot. You know, you will agree with me that anytime students hear the word examination, some students might be crying. Don't let me say some students, even us, even the teacher, when we were in school and our professor said, oh, tomorrow you are going to have a test, you know, we'll be feeling anxiety. So, you know, we might be exhibiting a kind of phobia. Oh, this guy did not inform us before now. Why will you tell us to, do the test now? But we found out surprisingly that when you give, the assessment in what? In form of technology, when you use technology to give the assessment, or when you use AI powered tools such as Kahoot, we found out surprisingly that people, our students, enjoy the lesson, enjoy the assessment. In fact, they are motivated to do the assessment in future. They are willing to participate, and they have a lesser phobia than their own counterparts who use, traditional writing and pen in their assessment. And you know what we did was also RCT, randomized control trial. We placed students in two groups. So we asked some of the students to use, Kahoot to have their assessment. And you know what Kahoot is? I used to use it in my in math with Lukgaf. So with my Alare Ishiro. And the Kahoot, Kahoot grades student based on the speed and accuracy. You know, the reason why it is very interesting is that they can see their result on their score on the on the leaderboard, and they can see how they are faring. And you see, if you give students, student question on count like this, you will see them cheering because they will say, "Oh, I'm leading Lagbaja with this so mark." You understand now? So when we try to run this as an experiment, we found out that AI powered tools is effective. So, and because it reduces phobia, it instills the enjoyment, and it increases the motivation. So students add when it comes to answering mathematics question. So the reason why I brought this is that apart from the relatable example you have to incorporate in your mathematics clinic, you have to ensure that you harness AI so in your teaching as well. Because of the time, so I'm going to conclude my lesson. So far, you will see that from my own clinic, students remember what they feel, they laugh at and relate to some of the concepts. In essence, when you want students to relate to what you are teaching them, so anytime you are creating your mathematics clinic, please ensure that so you use relatable example. And in my clinic proves that blending language, culture and humor into mathematics education also creates more focused, engaging and long-lasting learning. So if you are from Ijebu, the same way Dr. Kayode is doing, so try and also incorporate, you blend your language and culture into it so that the students can quickly, remember what you are teaching them. Also, I like I've shown and like we found that AI tools can multiply this effort by helping generating and personalizing content, and by helping in solving problem, and by giving a kind of motivation and reducing phobia when it comes to assessment. So I'm going to end this talk with the goal is not to teach students what mathematics is, but why and how it matters in their own world. So I'm going to stop here, and I thank you for your attention. So I'm going to take question from you if you have any. Any question, please? I can see from your chat, and if you ask your question there, maybe with the remaining 10 minutes or so, so I'm going to reply you. Any question? An apology, Dr. Adewale is currently on transit, and that's why he was unable to anchor it. I think I'm the only one in the studio. Okay, thank you, Mr. Tajudeen Odufeso. Okay, thank you, Mr. Ogunbowale Adeyemi, Mrs. Usiyemi Adefunke, So Mr. Soyinka Oluwaseun, and I can see one mathematically. Akomolafe Temitope, thank you very much. Mr. Sani Omolara, thanks for joining us. Sandra Kakinyele, Suwaib Adejoke Nasimot, Faith Akinbande, Sorungbe Ajibola Olaosebikan Bose, Ayoku Sokeye, Ikmot Tijani, Tajudeen. Thank you very much. CTech Edu Concept, Kende Alabi, Sani Omolara, Rahim Adebayo, so Fadeke Kolapo. You know, I might not be able to. Okay, thank you. Mr. Ajiwala mentioned the network issue is probably disturbing us to Ganusi this night. I hope that's why the organizer is trying to record it so that you can go back and Ganusi. So Bilikis Adejoke, Oyefela, Arile Sere, Ikmot Tijani. So I'm sorry I might not be able to see all of you. Ayokusoke, thank you very much for your time. So Ayokusoke mentioned quite inspiring and eye-opener. Double kundus for you. So okay, thank you. Kundus for you as well. Kundus for you for joining. So yeah, and my boss, Mr. Kendi Alabi, thank you very much for joining us. I think we are all together in this struggle. Kundus for you. So for all of us who gonna see tonight, thank you very much. And I hope anytime you come across this Agbako function, you know how to handle it. Any question, please? Any question? Probably if you have a question on how you can equip your Mr. Latif Adedimeji, thank you very much. Mr. Soyinka Oluwaseun, thank you. So Mr. Ogungbemi Oluwaseun, thank you very much. So yeah, Mr. Lawa Osibikan Boss, very interesting lecture, thank you. So that was my aim. I want to make it interesting so that you can also replicate same in your respective clinic. So any question? If there is no any question, okay, Mrs. Sandra Kakinyeli, yeah, it's indeed an eye opener to all of us. So please let us try to implement that. So yeah, thank you, Mr. Akintoye, Olanrewaju, Mr. Adepeju. So any other question? Okay, in the absence of no question, let me know if you have any question. You can reach out to me on my email, or you reach out to the organizers, Mr. Kayode. So and you know he's going to connect me with you. I know probably in few weeks time I should be hearing, I mean, testimonies from you that okay, now Lukgaf, I've created my clinic and probably you are going to invite me to the inauguration of your clinic, so which is going to help not only students from Ogun State, so but all the students across Nigeria. So thank you very much, everyone. And I'm going to stop here for tonight. So thank you very much and bye bye.
Hello, waiting for the second facilitator to join now.